Alright, here are the notes for linear inequality. This is a video, as you can tell, so if at any time something's going too fast, just pause it, write down what you need, and then or rewind it, get what you need. So the first thing is, we have a linear inequality, but in standard form. And it wants us to find out if the following are solutions. The following ordered pairs. Remember, the ordered pairs comes in X and Y. So in order to find that out, use your calculator and just substitute these values in there. Okay? And then make sure that it makes the statement true. For example, it says 2x, so I substitute the 2 minus 3 times whatever y is, and that should be less than 15. Well, 2 times 2 is 4. Negative 3 times 5 is negative 15. And then 4 minus 15 is negative 11. And negative 11 is less than 15. So this one checks out. We repeat that over here. 2 times negative 1 minus 3 times negative 7 has to be less than 15. This is negative 2. Negative 3 times negative 7 is positive 21. Well, negative 2 and positive 21 is 19, and 19 is not less than 15, so that one is not a solution. Again, that's too fast. Pause it. 2 times 3 minus 3 times negative 4 has to be less than 15. You have to follow your steps. 2 times 3 is 6. Negative 3 times negative 4 is positive 12. Then when we add those two, we get 18. It's supposed to be less than 15, which is not. So this is also not a solution. And then the last one, we repeat this process one more time. 2 times 0 minus 3 times 0 has to be less than 15. This is 0 minus 0. 0 is less than 15, which is a true statement. So we find out that 2 out of the 4 ordered pairs were solutions. Okay? When graphing linear inequalities, it's a way to show all the ordered pairs that are solutions. So the steps to graph that, the first thing we want to do is put the inequality in slope intercept form, which is the one we've been using most of the time, the y equal. Be sure to flip the inequality symbol if you multiply or divide by a negative. Make sure you do that. Once you've done step 1, which is again to put it in slope intercept form, to graph the line, use a dotted line for less than or greater than, and a solid line for less than or equal to or greater than or equal to. Because they're equal to, they get a dotted line, a solid line, meaning it can equal that. And the last step when we're graphing is to shade. To shade them, you shade above the line when it's for greater than or equal to, and below the line for less than or equal to. So again, if it's greater than, then it has to be more than the current line. So we're going to shade above that line. If it's less than, it's going to be less, so we're going to shade below. All of this starts to make sense when we do our first example. Notice they give us an equation in standard form. We're going to go ahead and solve this one for y. Get y by itself. Isolate the variable. We keep the symbol the same way for now. Then we're going to divide by negative 3 because we want a positive y at the end. And that's going to leave us with y, and I have to flip the symbol because I divided by a negative, is greater than. Negative is positive, so positive 2/3 x. Positive 15 divided by negative 3, negative 5. Now I have my slope, that is 2/3, and my y-intercept, that is -5, and I'm ready to graph. The only other thing I'm going to pull out of here is just this part, so that I know that I have dotted, and it's going to be above. So let's see what that looks like. I'm going to start at -5, which is right here, and my next point is going to go up 2 and over 3, 1, 2, 3, and I can connect them already, and it's dotted because it's not equal. And then the last part, it says y is greater. So if y is greater, you shade above the line. You shade above the line, and we're done. That's how these are supposed to look. Again, you need to see the steps again, rewind it, and then play it again and pause. The next sheet says solve each inequality by graphing. So again, the first step, we're going to solve it for slope-intercept form. We're going to add the 2x, all things that we've been doing. 3y is greater than 2x plus 6. We divide by 3. We end up with y. There's no flipping because we didn't divide or multiply by a negative. 2/3 x plus 2. Now that we have our slope of 2/3 and our y-intercept of 2, we're ready to graph. When we graph, we start at 2. And our next point is up 2 over 3, 1, 2, 3. Up 2 over 3, 1, 2, 3. And again, it doesn't equal, so it's dotted. And again, it says y is greater, so that value is above the line. Because it's greater, it's above the line. So far, so good. Alright, next one. Again, I'm going fast, but you can stop, rewind, and play. We're going to solve this one for y. We're going to subtract the x. That gives us -3y is greater than or equal to -x minus 6. We're going to divide by -3. Remember, we divide all parts. So we have y. We're going to flip because we divided by a negative. Negative is positive. 1/3 x. Negative is positive plus 2. So we have our slope, that is 1/3, and our y-intercept, that is 2. So we are ready to graph. In order to graph, we start at the y-intercept of 2. And our next point is going to go up 1 and over 3, because that's what the slope is. Up 1 over 3, 1, 2, 3. Up 1 over 3, 1, 2, 3. This time, the line is equal to, so it's solid. Sorry, it took me a minute to get that one in there, sorry. And it's less than, so if it's less than, it has to go below the line. Below the line. We shade below the line. Alright, the last two for graphing. This is just y is greater than 3. And the way we graph this is exactly how we would graph y equals 3, except for the shading at the end. If it was y equals 3, then at the y-axis, I go to 3. And then I draw my line that is horizontal because it has no slope. The only thing is that this line is not equal to, so it's going to be dotted. And then I look again right here. This is facing y, so y is greater. So if it's greater, we shade above the line. Above, because every value is going to be greater than 3. And number 6, x is less than or equal to -4. Just like graphing x equals -4, we're going to go to -4 on the x-axis. 1, 2, 3, 4. And we're going to draw a line that is vertical. In order to do that, this one is going to be solid because it equals that. So I'm going to draw a solid line through -4. Then we're going to look at this and it says x is less than, so all the values that are less than x are going to be to the left of it. So that's how we graph x is less than -4. So there's a look there at what those graphs should look like when they're inequalities. Very similar to the way we do equations, but the inequality means that we're going to either dot the line or make it solid, or we're going to shade above the line or below. Our last part here for our video, and this you'll do in your calculator, it says which of the following points will be solutions to the inequality. Again, your points come in x and y, so we should substitute those in to the equation and see if it makes it true. If it makes it true, it's a solution. If it does not, it is not. So I'm going to do the first two and you can finish the rest in your calculator, even though these are the notes. So our y, we substitute that in. So first I'm going to write the equation so we're reminded of it. And then we can see where we substitute all these values, because I know some of us are still unsure sometimes. So I need to substitute the 1 where I see x and substitute the 0 where I see y. So if I do that, 2/3 times 1 plus 2 should be less than 0. At least that's what we're trying to prove. When I do that, 2/3 times 1 is 2/3 plus 2. 2/3 plus 2 is 2 2/3. And then you ask yourself, is 0 greater than 2/3? No, so not a solution. So then we do the next one. Again, they come in x and y. And this time I won't write the entire equation because we should know it. So the 8 replaces our y. That should be greater than 2/3 times 4 plus 2. 2/3 times 4, it's 8/3 plus 2. 8/3 is the same as 2 2/3. And we're still adding 2, so that is 4 2/3, which you don't have to worry about because you do have a calculator. So this should say that 8 is greater than 4 2/3, which it is. So this one is a solution. So you would do that for the rest of these and find out whether they are or not solutions.